Hello. We're going to continue with 4.3, finding probability using sets, day 2. Put the date, Friday, May 8th. So we're going to define the Venn diagram. I think we know that from elementary school and from yesterday's lesson. The intersection. I also want to make sure that we know it's referred to as the and word, okay, and the symbol. Union is referred to the or word and this symbol, okay? Now, the empty set occurs when there's no intersection, okay? So when there's no intersection, you use this Greek letter. So there's empty set uses the Greek letter phi, okay? When we talk about an empty set, we're talking about a disjoint set. So there's nothing in there, okay? So those are synonymous, okay? We probably don't even use the word set. So we say there's no intersection. It's equal to phi, okay? So therefore, we'd say, for example, if the intersection of A and B were equal to 0, we'd put a line through it to denote the empty set, okay? And then we'd say that the probability of A intersecting with B would be 0, okay? So when we're just talking about what's shared, right, we put a line through the 0, and when it's a probability, we just write the normal 0, okay? So mutually exclusive, okay, so if they're not sharing anything, then this would be an example of no intersection, okay? Okay, so we'd say that the probability of A intersecting with B and they are mutually exclusive, okay? Probability problem will be down further down in the lesson. This formula for additive principle of two sets we're going to use. Note number 1, probabilities can be calculated using Venn diagrams. Probabilities can also be determined using the additive principle. We're actually going to do this first and then work backwards to draw a Venn diagram. Okay, so we're going to do that first, and then we're just going to go back to a Venn diagram. So we're going to work backwards. The additive principle is a formula. So the probability of A or B, so this is the union, okay, but it's also called or, all right, is the probability of A plus the probability of B minus the probability of A intersecting with B. So we call this the intersection. Hope you can read that. So that's the intersection, okay? And it's also referred to by the word and, okay? So make sure, so make sure that you highlight that, okay? Because otherwise you're going to be stuck with some of the problems. All right. So when something is not mutually exclusive, they intersect. Okay, so it's not mutually exclusive means they intersect. Okay? Mutually exclusive means they don't intersect. Okay? So when I subtract the intersection the probability of the intersection, I can have either the probability of A intersecting with B to be 0, which is here, okay? Therefore, they're mutually exclusive. In other words, it would be the formula where these are actual values, and then this would be gone because this would be 0, okay? And then, or I have another option where the probability of A intersecting with B isn't equal to 0. To 0. So therefore, they're not mutually exclusive. Okay? All right. Given the sample set S, set A, and set B, answer the following questions. So we have to determine the missing probability, state if set A and B are mutually exclusive, draw the appropriate Venn diagram. So the sample set includes all faces of a die, so we could have put maybe the letter S there. I'll do that for your handout. Where A is all of the even numbers, B are all of the odd numbers. So the union, okay, so this is union, or, okay. The probability of that is 1. Probability of A is 0.5. Probability of B is 0.5. And the probability of the intersection we need to find. Okay, so we're going to use in I, we're going to use the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersecting with B. Now we're going to take all those values that we were given, okay, and we're going to sub them. So the probability of A or B is equal to 1. Probability of A is 0.5. Probability of B is 0.5. And, well, we don't know the probability of the intersection. Okay, so we're subbing all that in. So the probability of these intersecting, or sorry, the union, my apologies, is the union. Probability of A is 0.5. Probability of B is 0.5. Subtract the probability of A intersecting with B. Okay, so 1 is equal to, add these up like normal. Okay, well these cancel each other out, right? 1 and 1 on each side is 0, right? So 1, if I want to, I can move this over to the other side. I really don't have to. I'm doing this not knowing really if it's absolutely necessary. Hopefully you can see that, right? So I'm solve for the probability of A intersecting with B, right? So I'm solving. So I get 0 is equal to negative P, A union B, or sorry, intersect with B, and then that's divided by negative 1. I really shouldn't have to do all of this, right? But I am doing it because I think that maybe some of you need it. So 0 divided by negative 1, that's 0 equals, and then negative divided by negative is positive, the probability of A intersecting with B. So hopefully if you could decide, right, like right from here, that the only answer for this probability would be 0, because 1 minus 0 would be 1, right? Then ideally you would have seen this, right away. Okay, so double I, since the probability of A intersecting with B is 0, right? Therefore, like what we set up here, right? They are mutually exclusive. A intersecting with B is a disjoint set. So A and B mutually exclusive. Now, does that make sense? I hope so, because in triple I, we're going to show why that makes sense. So if the sample set S includes all faces of a die, and we can see that so if S is all faces of a die, okay, and I are the even numbers, well, that's 2, 4, 6, and odd numbers are 1, 3, 5, right? So then that means that I can see that none of these numbers in A are included in B, means that they're separate. So S is all faces of a die. So A include 2, 4, and 6. And B include 1, 3, 5. We can then understand that the probability of A is equal to all the possible outcomes in A, which are 3, divided by all of the outcomes in the sample set. Well, there's 3 here and 3 more, so that gives us 6. Well, 3 over 6 is 0.5. Well, it's not a very nice A there. Okay, so that is what this is, right? So likewise, the probability of B are 3 outcomes, 1, 2, 3, out of all the possible outcomes. Well, there's only 6 in total. So the probability of B matches this probability. Okay. Now I did do something. This has to be 0.6. I'll fix that on your paper. Okay. So the sample set S is defined by S includes all the numbers 5, 8, 10, 25, 31, where A are the numbers divisible by 5 and B are the odd numbers from this master list. Okay, so S is the master list. Okay, so we're given these values. I've changed that. I'll put that on your handout. We want to determine the missing probability. So the missing probability uses the formula. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersecting with B. So we're going to take all these values here and we're going to sub them in. So probability of A or B, which is the union, probability of A, probability of B, and the probability of A and B. We don't know. Okay, so probability of A or B is 0.8. Probability of A is 0.6. The probability of B, 0.6. And we don't know the intersections probability. So do the math. Oops. It's 1.2 minus the probability of A intersecting with B. So I'm going to solve for the probability of A intersecting with B. Okay. All right. So we move the negative 1.2 over. We subtract. Okay, so this is like a negative 1, right? So we divide both sides by negative 1. What do we get? Negative divided by negative, 0.4 is equal to the probability of A intersecting with B. Okay, so that's our answer. Now, based on that, since the probability of A and B is 0.4, okay, and that's not 0, okay, therefore A and B are not mutually exclusive. Now that's important because it influences how I draw my Venn diagram. Okay, so my Venn diagram has to have overlapping circles. Right? All right. So when S is the sample set of 5, 8, 10, 25, and 31, okay, and A is here and B is here, we've got to figure out, well, what do they share? And I have a feeling I'm going to need a bit bigger of an overlap. Okay, so we said that A was the numbers divisible by 5. Okay, so is 5 in this category? Yes. Is 8 in this set A? No. 8 is not divisible by 5. Is 10? Yes. Is 25 divisible by 5? Yes, it's included. Is 31 divisible by 5? No. Now, I can't immediately put 5, 10, 25 here because it might need to go in the intersection. Okay, so this overlap here is A and B. Okay, so that's very important. Odd numbers. So if B are the odd numbers, okay, so B from sample S, right? Sample set S. So is 5 an odd number? Yes. Is 8 an odd number? No. So it doesn't go in B. Is 10 an odd number? No. It can't go in B. Is 25 an odd number? Yes. Is 31 an odd number? Yes. Okay, so this is really like about finding a common multiple, right? Or a common divisor, right? Common factor. What do we see in A that we also see in B? Well, we see a 5 and we see a 25, right? So what do I see in A that I also see in B? Well, I see a 5 there and I see a 25 there. So really I'm focused on what's overlapping, what's intersecting, what's shared, okay, before I then fill in the rest. So then A, does it include 5? Yeah, it still does. I need a 10. 10 just happens to be outside of the intersection, okay? So where I'm intersecting is there. There. So A and B, they're not only the pink, but they're the green as well. Okay, so they're both. Alrighty. Okay, so B. So I have a 5, right? Because it's still part of the pink, the 25, but the 31, right? Then I have to check, do I have a 5? Yes. Do I have an 8? No. Let's put an 8 here, okay? It's still in the sample set. It just doesn't belong to the A, which are numbers divisible by 5, and 8 doesn't 8 is not part of B because 8 is not an odd number, okay? The other thing I wanted us to see is what's the probability of A? Well, it's 1, 2, 3, so 3, there are 3 desired outcomes, right? Out of how many in total of the sample set? 1, 2, 3, 4, 5. So 3 divided by 5 is 0.6. So the probability of 0.6, right, is here. And then the probability of B is 3, 1, 2, 3 outcomes out of how many in total? 1, 2, 3, 4, 5. So that's 0.6. Okay. What is the supposed probability of the intersection? 0.4. Is that true? Well, the probability of the intersection is equal to 1, 2 out of 1, 2, 3, 4, 5. Well, 2 divided by 5 is 0.4, which is 0.4, okay? The other thing, the sample set is always equal, the probability of the sample set is always 1, okay? So that's always 100%, okay, which is 1, because the sample set is including everything. So when you get to a question, I think it's the last one about simple events, right? A, B, C, right? All of them added together have to equal 1. That's the key for the last question that you're being asked. All right. Probability the student is taking calculus is the probability of calculus is 0.4. Probability that a student is taking physical education is the probability of PE is 0.5. Probability that a student is taking calculus and, so that's the intersection word, is the probability of C and PE is 0.5. Determine the probability that a student is taking calculus or, that's the union word, okay, so the union, physical education. So you want to determine the probability, find the probability that they're taking calculus C or PE. Okay? Well, that's the same as finding. So therefore, find the probability of C or PE. Right? All right. So we're going to have to use the formula up here. Okay? So probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersecting with B. Okay, so we're going to so this is what we're finding. Okay, so now we just transfer. So this is the A is calculus, union of B, which is PE, is equal to the probability of calculus plus the probability of PE minus the probability of the intersection of taking calculus and PE. Okay, so we're going to sub in probability of PE of 0.5. Probability of calculus and PE is 0.05. What else are we missing? Oh, the probability of calculus. Probability of calculus is 0.4. Okay, and we're trying to find this, right? So we don't know what this is. So probability of calculus is 0.4. Probability of PE is 0.5. Probability of taking both of them is 0.05. So we add these up. So this is 0.9 minus 0.05, 0.08. So you just type it into your calculator. So therefore, the probability, probability of taking calculus or PE is 0.85. So if I didn't show you this because I had my video camera and my paper was not lined up, so I subbed these values in using what was given. Probability of calculus 0.4 was told to me. Probability of PE was told to me of 0.5. The probability that they would take both calculus and PE was 0.05. Subbed it into the formula. That was the formula that was given at the beginning of class. Did the math, and then the probability of taking calculus or phys ed is 0.85. Have a good weekend. It's Mother's Day on Sunday. Don't forget your mums.